Thanks, Peter. Hi, everybody. Thanks for joining today. Yeah, I just wanted to, before we move into the slides, it's a technical presentation. There's not a lot of slides, so it's not death by PowerPoint. But I'll just give you a little bit of background about how we've arrived at where we are with the Hypertrax GR8 coating. Heck, back in 2015, we were approached by Network Rail. We'd already provided a corrosion coating for the network, and they came to us with a problem on switchware. And they actually said to us, like, you've got, you work in lots of different industries, oil and gas and automotive and downhole tools and stuff, and you provide coatings that help prevent wear on strategic components. Is this something that you could help us with rail, and particularly switches, trailing switches at the time? And of course the answer was yes. It was, as we say, it was a technology transfer. So we were asked to do a piece of work to come up with some ideas about how we could put our coating on the specific high wear areas of rail. So we set about doing that. That led to the nomination of some trial sites, and we were nominated a lead reviewer. We had a couple of trial sites, and the idea was to put coated switches into the sites and then compare them against, compare them against the uncoated switch performance of the previous one. So it was a very simple kind of business case, really. Unfortunately, about 18 months in, we lost our lead reviewer because he left the company, and we were nominated a new one, and that actually extended the process because it was decided that the new lead reviewer wanted additional trial sites. So we started again, in effect, although we'd been getting positive feedback from the original trial sites. And this actually happened to us 4 times throughout the journey, and the journey being to try and get full Network Rail product acceptance. So we lost a couple more lead reviewers. In 2021, we were given the opportunity to present to Network Rail of the feedback from the trial sites, which was all very positive, and the results of and it was all RDMS data from Network Rail. It wasn't our data. It was fed directly from the trial sites, and at that time it was decided that we needed to do a little bit more. So we went down a couple of other routes to prove the worth of the technology. Eventually, a guy some of you will know called James Dean, who was route director for LNW, he stood up as a sponsor, and eventually we got approval for James's route, and that in the middle of last year led, following the 8 by then trial sites information we'd gleaned back and the positivity of that led to full Network Rail approval, and we're now up and running and supplying not only switches but stock rails as well, which was an idea that Brian Whitney had. So that's just a little bit of background as to where we are today, and I thought it'd be a good opportunity just to take you through the slides and tell you a little bit more about it. So my glasses on for this. So what is it? It's a carbide coating system, and it's applied to the particular areas of wear within the S&C. And these areas of wear are well known. It seems to be on a particular area across all types of switches. As you can see on the picture, that was our version 2, which was a hexagonal pattern. That patternation is about 200 microns thick. They're very thin. Doesn't affect any of the operability of the switch, or it sits within the manufacturing tolerances. But what it does. Sorry, I didn't get any of that.
Yeah, somebody not muted. If you could make sure that you're muted, except for Steve.
So yeah, shall I go again? Yeah. So yeah, but what the patternation does, although that's only 200 microns thick, it actually between the patternation there's in effect wells, and when you put the lubrication on, that lubrication we found through the trial sites actually sits in the wells and actually becomes a friction modifier. And certainly helps the Hypertrax coating. So again, that wasn't something that we kind of specially designed, but it's certainly a positive that came out of the trials. As it says there, the coating is sacrificial, but it's designed to avoid interventions that you would normally get with uncoated rails. So on some of the trial sites, or most of the trial sites, we were finding that when they were going out to actually carry out inspections and weld repairs after a nominal time, they were finding that none were needed. And these interventions would have been very expensive for possessions and etc. So the sacrificial coating was actually doing its job in effect. And eventually, after it wears away, the switch then just becomes a normal switch. So what was it developed to do? Well, it's just about side wear on S&C components. Clearly, it's to extend the life and the cost benefits with that. Reducing the maintenance, and something that we also kind of got we discovered along the way was not only is it keeping the interventions for repair at a limit, it's also reducing boots off ballast, which is clearly a good thing. It meets all the network rail challenges, and as part of the approval process we went through, everything on a safety and operational level had to be checked and ticked off, and there are no negative safety implications whatsoever. Next slide, please. So this is a very simple graph, kind of gleaned from an awful lot of data from the various trial sites, and the orange blocks are the Hypertrax, and the blue are the uncoated. So as you can see, this graphically explains that the coated rail is lasting a lot longer before to first maintenance, second maintenance, etc., down to the first weld. So as I mentioned earlier, all of the data is RDMS data from the trial site, so it's nothing that Alphatec have come up with. And although the trials were varied across the piece, some were, as Nottingham Station was very, very impressive. All of them came with positive results, and the financial benefits that came from that as well. Next slide. So this is just our certificate from Network Rail. As I mentioned, the initial one was for LNW only. That gave us the opportunity to actually put more switches in there whilst we were going through the process. And then following a complete review of all of the information that we fed to Network Rail, we were given full product acceptance in the middle of 2024. On there, you can see we were given some monitoring sites, and there was some stipulations on where we could put it. But this is actually getting expanded, and we do an awful lot of depot visits and meeting with people to go through this kind of thing we're doing today. And what comes out of that a lot is, well, why is it only for switches and stocks? And we've spoken to technical authority about this, and they've said, well, look, if it could help on other components, as you see there, from check rails, wing rails, IVJs, they would be happy to allow this to happen and monitor them in the same way as we have done with switches and stocks. So it says on the scope of acceptance, it's a standardized coated area. I think what was really important for us was that we had to make the process of people being able to order coated switches and stocks very, very simple. In fact, it had to be business as usual. If we make, because of my time in Network Rail and knowing how that organization works, I said to the guys, if we make this difficult, for instance, if you say you need to provide us with a drawing of where you want the coated, it won't go, and we have to make it really, really straightforward. So Brian Whitney got involved at the beginning. He specified the actual coated area, which is exactly the same on any type of switch. So we don't have to look at it and say it's an E switch, so this is a different one. It's a very standardized approach. So as is the ordering system through the standard Network Rail Enroll system, And all that needs to happen from the route engineer's point of view is the write in the comments box, coated rail required, and then the next thing they know is that their coated rail turn up on site. So it's a very, very straightforward system, and we are looking at opportunities to actually coat other components as well. Next slide. Again, this is a little bit technical, but this is just showing you where exactly we're putting the coating on the switchblade, on each and every switchblade that we get, and the same for the stock blade. And this technical requirement was from Network Rail. So they're the ones who decided exactly where the problems was and where the coating needs to sit. Next slide, please. Again, we've touched a little bit on lubrication. After about the second trial, we were asked by Network Rail to, after we've done our coating, to actually start applying the lubrication on site. And we certainly got good feedback from the engineers saying that they were delighted that the lubrication was really staying in situ, which clearly has a huge benefit. And hand in glove with the coating, the wear resistance coating, we were asked to use the Interflon product, which seems to have worked really well, and we continue to do that with the switches we're producing for normal orders today. The inspection, very much as I said earlier, is very much the same as normal inspection. There's nothing extra needed. One kind of positive from the very long journey that we ended up having to approval was we really were put through every hoop by Network Rail's technical authority to make sure that this coating, although very, very thin, didn't have any detrimental effect on the normal standard operational business. And we ticked all of those boxes, hence leading to full network approval. So a few things there. It's normal rail conformity. The coating actually starts with a wear scar, then beds in. So we know what we're looking at. We know how it should perform. The inspections are exactly the same standards, and it doesn't mask RCF, and it doesn't mask any processes that needs to be done in inspections. Next slide, please. Yeah, the grinding, you need another form of grinding disc, which we've got information on to actually remove the coating should it ever need to be taken off. That's a diamond grade because standard equipment wouldn't touch it. It's, again, by the same token, it's exactly the same equipment that standard Network Rail issue. So there's no new equipment needed. It's just a different grade of grinding disc that's needed. And the welding, again, this was looked at length. No techniques, all standard techniques, and just remove the coating just around where the weld repair is going to take place. Next slide, please. This is just a little bit about, and just if anybody wants, we can actually provide you with this presentation in PDF form. Should anybody want this afterward, this is just a bit of information about what we've already covered, really, about how you order it. It can be specified on new S&C at the current time. One question we consistently get asked is, can you go out on site and reapply it? And although not impossible, it's not something that we've done because we've been very concentrated on getting the new S&C kind of up and running first. But it's something that we have been asked more than once to have a look at. And just some contact details there. And then finally, just a few testimonials from some of the many people along the way that we've worked with. We're getting very positive feedback. Clearly, the positive feedback is mainly from the trial sites, which were very, very multi-years. The original trial site at Stratford, which is the one at the top of the page there, that we know that that's still in track and it's still performing. It has been repaired, but it's seen a big benefit as Adam mentions there. So yeah, so it's very positive. We're certainly seeing a lot more coming through, and we kind of ended up with a slightly different set of problems of how we're coping now. And the last request from technical authority or suggestion was, this seems to be all for new maintenance items. Why are we not looking at renewals? So I've actually started to contact the renewals organisation, and we're trying to, because it would actually be as easy, but probably easier for actually doing renewals, which are built up at the S&C manufacturers. So yeah, so that's the presentation. I hope that's been useful. That's the journey and where we are to date. So if you've got any questions, am I answering the questions that's popping up on the screen? They're not staying very long.
Steve, I like to host for you.
Yes, please.
So,
yeah.
Steve, thank you very much for taking us through your presentation. We have now started getting some questions coming through on the chat. So I will ask the first one, which Daniel Pike has posted. You've intimated this slightly, but can you just tell us from start to finish the time it took to complete the product approval? Product acceptance, technically.
Do I have to? It's from the start. This was mooted in 2015, and we got partial product acceptance in 2023 and full in 2024. So 9 years in effect. As I said, Peter, one of the problems we had was the movement of staff, and we kind of, we were just up and running with a new lead review, and then when they moved on, human nature, I guess, but the new reviewers kind of said, well, I want my trial sites in. So we kept, in effect, even though we were getting positive feedback, we kept having to reset. So that was a big factor in the amount of time it took.
Can I ask a follow-on one for you, please, Steve?
Yeah.
Going through a product acceptance process includes a business case associated with it. You've given us a qualitative talk here. Can you put some numbers behind this in terms of what the upfront cost implications are and what estimates have been made for either a particular switch or a group of switches on the extended life and therefore the return that comes from it? I realise all the safety benefits and so on that you've put out, but can you give us the business behind it?
Yeah, it was very simple actually. And I think it's worth pointing out that although it's a technical coating and there's a lot of science behind it and everything, the original business case, as a kind of a layman's business case, if you like, was if you put your coating on our wearing switches, will it make it last longer, and will we have to do less repairs? So that is a very, very kind of basic premise for how it all started. If you take the Nottingham trial site for one of the 8, what we found there was, and the switch, we said this is how much it would cost to coat a switch, was around about 2,500. And then when you take the data from the trial sites such as Nottingham, and they, in effect, I think I'm right, and they said they avoided 4 interventions that they would have had to go in with a team and a weld repair, and I think circa 17 to 20,000 pound a time. So they avoided 4 of those. So if you put the cost of the coating against the cost of the savings, and not only did they avoid the intervention, they freed up people to do other things, and the boots off ballast. So generally, that's what we push across to the engineers: is this is the cost of it, and this is the cost benefit of the savings. And not everybody has always kind of seen that, but the engineers certainly see that it's kind of a straightforward thing to do.
Thank you. As well, go to the next question. I'm assuming this is Jose. Put me right if I've got it wrong. Jose Ramirez, would you like to ask your own question, which is about the physics and the interaction between wheel and ram?
Yes. Hello. Well, thank you, Steve, for the presentation. So, just my question is around Was it really the friction coefficient that this coating is having? Like we know in the switch rail with the wheel, the metal to metal friction coefficient more or less is assumed to certain levels, or it could, if it's higher, it could lead to a risk of wheel climbing. In these cases, in the switches, so yes.
Yeah, it's
What is it?
right. As we mentioned, yeah, thanks for the question. As we mentioned, we had to go through all of this with technical authority. The simple answer is it's exactly the same. There is no difference, and the wheel climb aspect was one of the boxes ticked off that we had to prove that didn't occur, and it
Okay.
doesn't.
Okay. Okay. Yeah, you mentioned before there was no safety implication, and that's
No.
the overall.
No, and as you can imagine, Network Rail would need to make absolutely sure. I mean, it's the fact that it's only 200 microns thick is the key, really. It doesn't affect anything. It doesn't, and even when people say, well, what about the train wheels? Well, it's going over that on such a short area, 2.9 meters, I think, that it's having no effect on that either.
All right. Okay. Thank you.
Okay, thank you.
Steve, I suppose an immediate follow-on from that, looking at what Alphatech produce, and they produce non-slip coatings for metals. Would there be advantages of something that was even more resisting friction in terms of reducing rail wear or wheel wear?
Well, we're certainly kind of looking and talking to the people along the way, and engineers are always the ones who are full of ideas. And as I mentioned, we are actually on version 3 of the coating, the original one. So I think the point I'm making, Peter, is we're always kind of, happy to talk about how we move things on. The original patination, if you remember the one you saw, it was hexagonal. The original one at Stafford back in 2017, that was actually rounds. But in looking at that site, this is just to give you a flavour of how we're happy to kind of progress and look at future technology. We realised we didn't have enough. The rounds didn't accommodate enough graphite area, and we decided then to move to the honeycomb, which gave us a bigger percentage of graphite. We've actually since moved on from that because we've gleaned more information about when we've gone to track and look at it, how it's performing. So we're now the patination, if you saw it today, and we need to put another picture in the presentation, is a diamond, which actually gives us even more benefit. We leave the kind of troughing as the benefit is the friction, but we also, that gives us flexibility in the switch, because a solid graphite area probably wouldn't flex as much as we would want it to, but because we leave the troughing in there, because we know the switches move and flow and everything, so that accommodates the switch movement as well. But to answer your question, yes, we would always be happy to look at future developments.
Okay, thanks. Justin, would you like to join us and ask your question?
You guys hear me okay?
Yes,
Yeah,
loud and clear. Thank you.
Hi there. So I was very interested in your comment about masking RCF measurement. I'm assuming that's the eddy current measurement you were referring to.
Eddy current and dye pen.
Right. Okay. Very interesting. So my question is, have you seen the RCF developing through the coating, or does it stop it, or it slow it down?
Well, that was an interesting one, Justin, because when we I'm getting feedback. Do you want to just mute, Justin? Yeah, thank you. Yeah, what we discovered at the Nottingham site again, I think what we discovered at the Nottingham site was that they said that it seems to be significantly helping with RCF. Now, we certainly were on a journey to try and get product acceptance for the wear resistance coating for stocks and switches, and we decided that we didn't want to open what could be a can of worms, I guess, by starting to claim that this can assist with RCF. But it was a comment made by the engineers at Nottingham but we've not really pursued that. We've tried to concentrate on what the coating's designed to do.
Justin, would you like to follow up with your second question?
Yes. So a question regarding the grinding. I was interested to know what delay it provided. I'm afraid my phone was buzzing at me when you put your grinding slide on, so I didn't get to look at your grinding slide. But I'm interested in the impact on grinding.
The only thing I'll pass on Andy Clark's with me from Alpha Tech. I'll let Andy cover this one.
Yeah, if I may. Hello everybody. One of the metrics that we got back from the trials from Network Rail actually covered the amount of time taken for maintenance on coated switches. And certainly from the Nottingham one, in fact, that was the only one we got this feedback from, was that they saw no difference in the time taken to maintain an uncoated switch compared to a coated switch.
Thanks, Andy. I was more interested in the timeline, the extension it would provide for the life of the switch, because of course what kills the switch is that it's perfectly made when it comes out of the shop, and then because of wear we end up grinding it away. And I wondered what the delay was between the extension of that delay was by coating it.
Oh, I see what you're saying. Well, yeah. Across the 8 trials, we had differing, because the trial sites were different radii, there were different speeds, there were different traffic, all that business. So but they were all common denominator, where they were all suffering from high wear. So across the 8 trials, we did get differing results. But it's true to say that all of the results were positive. Some were spectacular, like the Nottingham site. Others were extended twice as long. So there isn't a definitive, if you put this on, it will make everything last twice as long before repair. But the general consensus was that it does extend the life based on the wear it's getting and based on the traffic and weight, etc. And what our it was a breath of fresh air, really. What our sponsor, James Dean, actually pushed for was, look, if we can get some benefits, and it's not just the Hypertrax coating, there's lots of other products out there which is pushing to give benefits. His take on it was we should take anything that's out there that's going to extend the life of switches, small wins across the board. And, there is a tendency sometimes to look for the holy grail that, you put it on and you never have to touch it again ever. But in reality, it's a life extension that's really going to give different results, but more importantly, all across the trials, all positive results for extending the life of the stocks and switches.
Thank you. Do you mind just popping it back to the grinding slide so I can read it while the other questions are being asked?
Thanks, Justin.
Thank you.
Philip, Terry's asked about application in other rails, in embedded rails and light rail profiles and so on.
Yeah, it can be put on any rail. We have actually spoken to tram systems, light rail. We're speaking with or have spoken with TfL and DLR. So the main drive for us was we couldn't do anything because everybody used the common denominator of Network Rail approval. So although we've had conversations with all of these other parties, the kind of common denominator was, well, we'll come back when you've got Network Rail approval. So because we haven't had it that long and because we're getting very busy now, we've got a kind of a process going on. So we're re-engaging with these people. But basically, the coating can be applied to any grade or any type of rail. That's not the issue at all. We've actually got a trial site in at Nottingham Tram as well.
Nice. Is that on a standard profile?
I believe it is, yeah.
Right. Tony from Nexus has asked about train detection and any impact on conductivity and track circuit operation.
Yeah, no. None at all. No.
Patrick White, would you like to ask your question, which is about maintaining the surface after it's been applied during switch wear?
Yeah, so I guess my query is, once it gets to that point where you have to do that first repair, you are then, if I'm understanding it right, grinding the coating off, either to grind to correct the profile or to weld repair it. Does that then become a weak point within that switch that is more likely to break out again, because it is then again less, you've got that naturally less wear resistance there compared to the rest of the switch where the carbide coating's still in place?
Right. Thanks, Patrick. Yeah. Interestingly, what we find, I mean, you should be always borne in mind that come that time that needs to happen, and then removal is needed around the weld area. The coating has actually done its job. It's been on a protection of that switch. It's extended the life of the switch. So as I said earlier, it's sacrificial, and like everything, like a car tire or a Teflon pan, it will eventually wear off, but you've banked the benefits in that time. What we've found, interestingly, because there has been weld repairs done during the lengthy trials, what seems to be happening when we've been to site is where the virgin metal is, where it's been repaired, over time, the coating starts to kind of migrate from the actual coating across that area, and we're seeing kind of the coating actually reapply itself in a way across this area. Again, not something that was particularly planned, but it's just an observation we've made.
If I could interject.
Okay, thanks. Yeah, so you wouldn't. Oh, sorry, I was just going to ask, so you wouldn't recommend then, if there was a case where you had to make an isolated repair within the asset, basically removing it throughout the length of it so that it's consistent, you'd recommend still leaving the existing coating in place where feasible?
Absolutely, yeah. Literally, you're only just removing coating from the edge of the defect area. The rest of the coating would stay. And what I would also say is, in inspections I've made of coated switch blades that have been repaired multiple times, it's not that it's always in the same place. So you're not getting this, you've repaired that bit, that's the first bit that needs repairing again. It's been a slightly different area.
Yeah, okay. I think, it's something from a maintainer perspective, we just need to be smart with making sure that everyone was, because, quite often our teams might plan in a maintenance grind for an area with like a Haskell or even hand grinding. But obviously, we'd need to make sure that people aren't going to try and do something proactive and then accidentally go and remove coating on a newly installed coated switch.
Yeah, absolutely. I mean, one thing I should say as well, and one thing we've done throughout the journey is we have worked closely with Track. We're not about just saying, well, we've got product acceptance, we just coat switches and send them out. We're talking with people. If people have got questions, or if people want us to pop and discuss the coating with their group of engineers, we consistently do that, and that's part of the support that we try to provide.
Thanks for your question, Patrick. Thanks for digging into that. Ricky Llewellyn wants to know, is it 2.5K per switch or per set? I think it was per switch, but just confirm that.
The switch and stock. It's two, I think, per switch rail and per stock rail.
And there's a follow-up question there about light rail, which I think we've covered. Ian Ambrose I was asking about tramways. Any impact on noise? Graham Bleach would like to know.
No, not. It's pretty much business as usual against the normal switch. We've not been told that there's any noise impact.
And Daniel had a further question on different grades of steel. Is it just R260 or all the other grades of steel as well?
All grades. Actually, in a meeting with Track Technical Authority, the grades of steel came up, and they're saying, well, look, what about this premium grades of steel? And Dave Webb, who's the national track engineer, said, well, actually, if you've got a premium grade of steel, why not put the coating on that, and you can get a kind of double win then. So that was his idea. But no, the grade of steel, the profile of the switch, the type of switch. The only thing I would say is you just want to be putting this on. We've had people contact us and say, look, I've got a switch, it's wearing out every 7 years. Do you think you should I order a coated one? And we say no, because that you haven't got a wear problem. This is specifically because we don't want to be putting it in places where people don't have an issue, because that would only come back to bite us anyway. So we it's where you've got a wear issue. This is where you would consider extending the life of your switches by using the coating.
Thank you. And Ram would like to know, so you've talked about reduced number of repairs. Have you got a figure for the actual additional lifetime of a switch, a coated switch against a non-coated switch?
Well, I did kind of mention that a little bit earlier, that it was very different. The Nottingham trial site was very, very positive, and we avoided four interventions, at £17,000 to £20,000 a time. Some of the others, they avoided one intervention, but again, compared to what it costs. So it's very much dependent on where people are putting it. But we didn't get any negative. Every coated switch we put into the trial sites all had positive effects. But it's very difficult to be prescriptive because track conditions are different wherever you put in your switches.
Good, thank you. John Franklin Farrar, would you like to ask your question, please?
Yeah, thanks. It's been very interesting. One of the projects I'm on, we've got two very tight radius plane line curves. And in the invite, it mentioned about curved plane rails as being potential options. So on those sites, some TrackX analysis we've done has shown that side wear is the life limiting factor. So what are the next steps really in terms of other scenarios, and is that something that might be of benefit?
Yeah, I mean, John, we've been asked that question lots of times. We always get asked about other components, and curved rail, plane rail has come up. If that was wanted, I guess what would need to happen is that a request to put into Network Rail Technical Authority, say, look, we know this is used on switches and stocks, but we're looking to put it on tight radius curves where we've got high degrees of wear. And based on what they've talked to me about using, putting the coated onto other components, I don't see that they would have an issue, but it would have to come through them, I think, because clearly our product acceptance certificate doesn't specify plain rails at this time.
Right, thank you.
And I'm assuming there'd be a multiplying up if it's £2,500 for the limited application on a switch. If you wanted to put it around a curve, you'd be into tens or hundreds of thousands of pounds.
Well,
it's without knowing. I suppose the thing is, with the way we apply it, we might go down a slightly different route in the application process, which would, not add such a cost multiplier necessarily onto that. Much will also depend on the length of the rail as well. I think we're currently limited to maybe up to 25 metres at the moment that we could accept to our facility in one go. And then it's how we would process that. So there's a couple of things that we would need to do as a company on our production process, just to handle coating that particular length. But it's more a case of a bit of development from that side of things. So if somebody had a particular site and application, we'd be happy to discuss that and discuss what the cost implication would be as well.
Yeah, I think it's a very simple, it's again back to the layman's business case of the cost of doing it versus the cost saving. And I think it's always got to kind of come down to that. And, we would want to know what that business case, how it looked.
Well, that's exactly the case that we're going through on this project. And as I say, the TrackX analysis going to the high performance rail with lubrication still has a relatively low life on it, and there's not a lot we can do about the track geometry, certainly on one of the two sites. So it's really trying to understand some of the other capex versus opex implications.
Yes.
Is this something? Is this a product that may support that in the future? That's not obviously a question to answer now, but we're just trying to gather evidence for ways that we can mitigate potential future problems where we are so constrained that there's not a lot else we can do.
Yeah, I mean, certainly we would definitely look at that. Not a problem, John. And if you want to contact me and give me a bit more detail offline, we can certainly gather some information. And to answer your question is, can it be applied to curve, plane switches? And the answer is, of course, yes, because the application is kind of free for all, really. That's not a constraint for us where we put the coating.
I did pass the details of this presentation to my client, but I don't think they've managed to attend. But what I'll do is I'll pass the details over and see if we can take it further. But thank you.
Okay.
Thanks for your question, John. Hopefully it prove fruitful for your investigation. Nick's asked a follow-up question on the certification on the lengths of switches and switch profiles, rail profiles that were involved in the trial certificate and I guess in the full PA certification.
Well, rail profile is any of the available ones. There's no problem with those.
Yeah. RT60, NR60, 156, C1, 60, any grade, any profile.
Any grade, any length, any angle.
Okay, great. Thanks, Steve.
Well, the length will be limited by what can be delivered to our site,
which is looking at the minute at 24, but it was a bit Pareto, really. We found the C's and the D's and the E's were 80% of the problem identified to us by Network Rail of having this excessive wear over a short period. So we're covering the kind of majority.
Yeah.
Fair enough. Good. Thank you. Paul Shapland, would you like to ask your question?
Yes, I think you sort of mentioned it briefly anyway, Steve, but
Hi,
I think
Paul.
how are you doing? Are you okay?
Yeah,
Long time no speak.
Long time, yeah.
No, Steve, what I was going to ask you, sir, is I think you started earlier about the approval process of this on, like check and wing rails, things like that. It sounds like it just starts with the request in and then maybe it builds from there. Is because I'm assuming that we don't have to go through the full process, even though there may be a little bit of trial in there to do.
No, absolutely, Paul. And what we made plain when we had our meeting with TA, because this came up and they said, look, if people want to put it on other components, then that they're suffering from wear, then we would just have to kind of do some trials. And I kind of jumped in and said, look, we're not willing to go through what we've gone through for 10 years. And they quickly said, no, you're not talking full-blown trials. It's like an observational trial. So somebody's going to try it. They gave me permission, and I did write out to people. I didn't get very much back actually, but they said if you can find people that want to try it on check rails, wing rails, IVJs, just let them contact, or you let us know that this is what they're trying to order, and we'll put something in place. So it wouldn't be a trial situation. It would be a first one in. We'll keep an eye on it. But to be fair, Paul, if it's working on switches and stocks and it's protecting, and in other industries, which clearly this is the technology transfer aspect of it, it would definitely have a beneficial effect on those products too.
Yeah, that was my assumption. I feel like you've gone through the pain once of going through all this, so to go through the pain again will be extremely frustrating. Yes. But no, I appreciate that, Steve. Thank you very much. That's great clarity. That. Thank you. Cheers, good to speak. Take care.
Yeah, you too, mate. Bye.
Steve, John Matthew has asked about desert conditions and sand, and whether that has any implications with the coating and creating any form of grinding paste.
I think that's an interesting one, because you think of sand. I can't remember if it's silicon oxide based material predominantly, I mean, the coating itself being carbide based, silicon type abrasives don't tend to touch it. I suppose the bigger issue might be with wear of other componentry, but then again, typically because the length of coated area is so short, I mean, basically it's one revolution of a wheel. I don't think you're going to see much issue from that.
I guess it's part of the wheel rail interaction as well, though, either on the wheel or particularly on the rail, if there was anything.
Yes.
Nothing you've measured?
No.
No.
Okay, thanks for your question, John. Tim's reinforced a question from Sam, which is in relation to the traffic and whether the tonnage that's borne on a route and over a particular set of S&C would influence whether it should be applied, it should be installed with a coated switch or not.
Well, I think the common denominator, as I said, we came across all different kind of tonnages and curvature and everything. Common denominator is if you've got switch rail, unless Andy will tell me different, if you've got wear, excessive wear, which is causing you all the issues that brings with it, then the coating would be worth putting on there to extend the life. Now, if it's extremely excessive wear, then it might make it last 50% longer. We don't really know, but it's it is designed specifically for, you've got a wear problem. If you put this coating on that surface, it will make it last longer. So it's hard to be more prescriptive than that, really.
If we go to the very extreme in terms of heavy load on the rail system, you're probably looking at things like the quarry lines in the Peak District. Now, one of our trial sites was actually on one of those lines, so you got extremely heavy freight going along, and it was only freight, probably to the point where the switch blades were getting past the into plastic deformation. But what we found with the coating on that was it still increased the life. To be honest, not a huge amount, but what it did do was dramatically decrease the number of weld interventions. So I think it decreased them by 50%. So that was where the benefit came in, in the extreme heavy. Now, I'm guessing as this is more a heavy freight depot, it's not necessarily going to be up to those sorts of extremes. So you could kind of see, you've got this sliding chart of, weld intervention reductions and then going up to weld and lifetime increase. It's one of those things, I suppose, from an engineering point of view. If you tried them and find you didn't get any benefit, don't get them again. And that's kind of the way we tend to work, is that if you find you've got a benefit, you're going to sort of have coated stocks and switches more frequently. If you don't find you get a benefit at a certain site, you won't use them again. And although there's 22,000 S&C sites across the UK system, basically they're all different. So as Steve's already intimated earlier, a lot of them, don't see heavy excessive wear, so we don't expect, those to be coated. It's those sites and identifying them, and you are the guys that will know where they are, that would, best have a coating benefit.
Thank you. And the last technical question that we've got in the chat so far, I'll hand over to, is it Robertus? Well, if they're not there, it was a question about the application and how is the matrix pattern achieved in the application? How do you actually go about making the coating?
Well, it's it's protected by IPR, the process, and how we do this. Now we apply it, but it's not painted on. I can tell you that it's actually put on as in a hot process spray, and it's been fully vetted. But yeah, to actually start talking about how we achieve what we achieve is probably not the wisest thing we could do.
Your magic sauce. There's actually there's another technical question coming from Rami as well, which is the thickness of the layer.
It's 200 microns, which is about, I think it's about 1/8,000th of an inch.
Right.
But even though it's that small, as I said earlier, it does have the benefit of where the wells are around the atolls, as we call them. It does hold the lubrication. Oh, that's the feedback we got, that it's holding the lubrication in situ much better.
The only other questions we've got are in relation to the availability of the slides, which I think you've said you're quite happy to post a PDF of those.
Yeah.
Yep.
If individuals wish to get in touch with yourself, I'm not sure if you could post one in the chat. If you're able to do that before we've wrapped up, then folk can download it from the Microsoft Teams chat.
We've not got the PDF. I've only got the one that we're looking at. So if people want to just contact me, I can create a PDF version and send it out.
Okay. So I'm going to draw things to a close and thank you. I'll start by thanking everybody for their engagement in all the conversation that we've had over the last 40 minutes or so since the initial presentation. Some really insightful questions and great answers. Thank yourself, Steve, and Andy, supporting you there in responding to all of that and for making the presentation. I'd like to thank everybody for attending today. Hopefully you have found it a useful session. If you have any further questions after this, if there's anything occurs to you, then please do get in touch. The content of this will be posted on the PWI's LinkedIn page, and there'll be a discussion group associated with it as well. So please go there if you've got anything else that you wish to ask afterwards. And then I'd just like everybody to show their appreciation. You can either unmute your microphone for a moment or two and give a round of applause, or respond via the Teams facility.
Like those, yeah.
Brilliant.
Brilliant. Okay, Peter, thanks for that. Thanks for
Thank
everybody
you
today. Appreciate your time. And,
just as we go,